I want to tell you something about yesterday's assignment and topic. I think I just kind of want to take a pass on the whole thing. I didn't love the assignment in the book yesterday once I looked at it a little more closely. I did send out solutions. Did some of you get that? I sent out my mass mailing list with solutions that I took pictures of from the solutions manual for all the odd problems. But I wasn't thrilled with it. I really would like to just have yesterday be, hey, look, here's some more identities you can do with some squared identities, and not get into all the simplifying and solving and all the other stuff that came up. If you really want, maybe later, I'll go through all those in detail, but I'm not going to ask you to do those kinds of problems. I'm going to specifically find the kinds of problems that I think are useful when it comes to applying these identities. And I didn't see very much of anything that was useful. I mean, the very last question was actually fairly straightforward and simple, but other than that, there wasn't a whole lot in there. I just tried to find ones that would just fit that one topic. I don't think I did a very good job of that. So if I can just take a pass on that, let's just kind of move on from the squared identities. We know that they're there. We know what they are. And then maybe we can just kind of move ahead and look at these ones. Because this is going to be really pretty intense right here. Enough to really sort of focus our energy and attention as it is. So is that cool with everyone, or is there something dramatic that you want to go over and take a look at from yesterday's assignment?
When we do go to turn like all our assignments in at the end of the week, do you just want us to turn in what we did for that one?
Yeah. So what I'm going to do is come test time, which will be next week. Monday is the day I've got planned for the test. Somewhere between Friday and Monday, I want to make sure that I have gotten the last 8 assignments from you. So going back the week before spring break, the week that started March 30th, you had a quiz on Monday, and there was 4 days of assignments. And then this week, there will be 4 more days of assignments.
So like from 5.4a to 5.5e.
Plus the review on Thursday.
Okay.
So 5.4a and b is 2. 5.5, there's 5 of them, that makes 7. And then a review assignment on Thursday, that'll make 8. And there was extra credit that, if you still want to do extra credit, I'll take them by tomorrow. Those are assignments from over last week, the spring break week. I'll take them by tomorrow, and they'll go on third quarter. Maybe we'll talk a little briefly about fourth quarter here just a second, too, for grades, because that's now becoming an official thing. Anyway, so I want those 8 assignments at some point. Just get them to me when you can. If you can label them 5.4a, 5.4b, and then 5.5a through would be great in the review. So let me just clarify how the grading is going to work, because we just had a meeting this morning where we kind of confirmed how it's going to work. Seniors, you're in a little bit of a different situation, but not really. So in terms of what this has to do with, this still applies to you too. Okay, seniors, we have a meeting this afternoon. Did you know that? Okay, I assume that you knew that. Third quarter grades are going to be third quarter grades. Now, the rule was that after the shutdown, your grades could not get any lower than they were on March 16th. So whatever they were then, nothing because of this shutdown could drop your grades, could affect you. They can go up. So that's for high school grades. Keep in mind, there's a whole bunch of, the college grade is still going to be based on everything, closure or no closure. But your high school grade can't go down. So if you haven't turned in any assignments, that doesn't count against you towards the high school grade. Eventually, it will count against you towards the college grade. But if you've done all your assignments, then everything's great. If you got a really bad quiz grade during the outage, I don't know if anybody really did, but that also wouldn't count against you. But it could help you. So third quarter, we're going to shut off third quarter tomorrow, and you're going to get a quarter of a credit just for third quarter on your high school transcript. Got that? Oh, you know what though? That's going to be really confusing because you're actually getting, you're getting 2 full credits for math this year. Do you remember that? You get a full credit for fall semester because it's a 5-credit college course, and you get a full credit for this semester. Regardless, you're going to get a credit at third quarter, which we never have done before, but we're doing it this way because starting fourth quarter, which will be starting like Thursday, it'll be credit, no credit as a default. Everybody gets defaulted into credit and no credit. You either get credit for it, but no letter grade to go on your GPA, or it's like you never took the course for fourth quarter. Not like a failing. There's no failing. There's no failing. There's either didn't take the course or you get credit. And then you're all going to have the opportunity, if you want to opt in, you'll have the opportunity to sign up for a letter grade, a high school letter grade for fourth quarter. And you can make that decision up till June 19th. And I am probably guessing we're going to be done well before June 19th. That's the official last day of school. So you can go all through fourth quarter and then decide on June 18th, you know what, I like my letter grade. I want that on my transcript. Boom, you're in, you get a letter grade. Otherwise, you just get credit or didn't take the course.
To know our letter grade throughout the quarter, will it be on Skyward, or would we have to contact you for it?
For fourth quarter?
Yeah.
I will be keeping letter grades all the way through.
Okay.
I'm keeping them all the way through as if, that's a good question, Anna, as if all of you are on the letter grade option. That's how I'm going to keep grades. So like if you didn't do anything for fourth quarter, you'd have a 0 in your grades on Skyward all through fourth quarter. If you have it'll be just like everything's normal. The only difference though, Anna, is you know how the semester grade, at least in Skyward, most of us do it, is just sort of a combination, a running total of the entire semester. But there's a fourth quarter grade that shows up as well. The semester grade, S2 grade, you'll have to completely ignore. It's meaningless now. All it's going to matter is Q3 grade, and then separately Q4 grade. Or T3, T4. Do you follow what I'm saying? The semester 2 grade is irrelevant now. That's not
like on our transcript, will it show up as like how our semester grades only show up? Would it show up as like 2 grades on there?
Yeah. Yeah, it's going to be a mess for whoever does transcripts. All I'm saying is, for now, don't ever look at semester 2 grades. That's going to be irrelevant. Okay. T3 ends tomorrow. T4 starts on Thursday. Okay. Now, for college grades, of course, you're going to get a letter grade. Although I did send out to you, I hope some of you got that email, that Central is now giving you the option of taking this course pass-fail. Meaning it would be attached to your Central transcript, but without a grade, therefore without grade points, it would not affect your college GPA. I don't know that anybody will want to do that, but it is an option for you. And you have, I think, until July 3rd or something to decide that. So we can talk more about that later if you want. So it's tricky. Basically, there's 3 grades going on. You've got third quarter grade for Pateras, fourth quarter grade for Pateras, and then Math 154 grade for Central.
So our third quarter grade was whatever it was when we left, or whatever we benefit from?
Well, it's what it is right now. Because whatever, I've only put in things that helped you.
Okay.
So if let's say, I know you didn't, Ed, let's say that you totally bombed that last quiz. If you had bombed the last quiz, I would put the quiz grade in and then check the no count thing. And you can see that in Skyward. There's a column that says no count. So it would show up as a no count, it'd be checked, and it wouldn't have affected your grade.
And like for fourth quarter now, let's say I bomb another test, would that have to go in as a like regular? Okay.
Yeah, and I have to make some decisions then about what I'm going to do about, dropping lowest scores on songs. We're not going to have very many to choose from. Mm-hmm. I guess I'll say this. I can't change what Central asks on their final. but I can make sure that what I ask on our tests, on your tests, and I anticipate there being 3 significant tests between now and the end of the school year in here, maybe a quiz as well, but 3 major tests. They're probably not going to be as rigorous as they normally would, simply because we're doing this. This is not an ideal world. I'm not always at my best. I'm sure one of you maybe have had a day where you're not at your best. We're not all at our best right now, and so I'm not going to hold you to the standard that I would typically have held you if we were meeting every day and, you know, bantering back and forth and going over stuff and working on it. So I'm going to try. I've not written your test for this section yet, but actually, let's talk about that real quick. Haven't written that test yet, but what I'm going to do is this Thursday is to be a review day. We're not going to meet live Thursday, but I'm going to record sometime between now and Thursday. I'm going to record a little review video for you. And in that review video, not only will I go over the 5 sections, which you can do on your own, but I'm going to highlight, look, here's what I want you to be able to do with this section. Here's what I want you to be able to do from this section. And so you have a better idea of, when all is said and done, what is it I really have to be able to show from all these sections we've done. So that should help you prepare a little bit for the test. And then once I do that, I'll probably be able to write the test a little bit better. And then I'll probably post the test Friday, then you'll have until Monday to finish it. Sound good? And you, Karen, I'm going to let you use all of your identities on your test. So I don't want you to memorize anything. I mean, I'd love it if you knew things, but this is not the. I said this before. I think this is probably the absolute worst time of the year in this course for us to be gone for this particular topic. This is, in my opinion, by far the hardest topic to try to learn in this way, and I'm just sorry. I don't know what to tell you. It's just the way it's happened. So I'm not going to hold you to some unreasonable standard when it's just not fair or reasonable to do that. Okay? All right, any questions before I get started? Because this is going to be a hefty one today. And I'm not saying that to sort of freak you out, but I just want to prepare you. It's going to be a little bit overwhelming, but it all kind of has a pattern to it. And it'll be cool when we get at the end. Okay, let me switch over then to the whiteboard. And what I want to do is lay out for you a couple of ideas. We're looking at the idea of product to sum. And sum to product. So the question is, what's a product and what's a sum and what are we doing here? The idea is, and you can see, if I go back here real quick, you may be able to see on the screen here that this first set of identities, which I'll derive all these for you, takes 2 products, right? Cosine times cosine, sine times sine, sine times cosine, cosine sine, and turns it into a sum or difference, but we know that addition and subtraction are the same thing. So we take a product and we can now write that product as sums of cosines and sines. Then we go down here and you can see we've got sums and differences that are turned into products, things multiplied together. And you might be thinking, well, why would we ever care about this one? I'll give you some examples when we get to the very end here. Okay, so what I want to do is I'm going to start with this product to sum idea, and it's going to get a little bit hairy in here, but just bear with me. I'm going to start with a problem that looks like this: cosine of We'll use A and B. No. Let me use X and Y. That'll make more sense later, I think. Cosine of X plus Y plus cosine of X minus Y. Okay, I'm not asking you to know why I'm starting there. All I want to do is use what I know about cosine addition identities to simplify this. Now, you might be thinking, what does a cosine addition identity look like? I will show you. Let me pull it up here real quick. It's these ones. You can't see them, so I will show them to you. Now, these ones. Remember that? Sums and differences. Sine stays the same. Cosine changes. So if you have those handy, please keep those handy. Okay, we're gonna work with both of these now. So I'm gonna go back and we're gonna go through a fairly lengthy process, but you're gonna see something. All right, cosine X, cosine Y. Sorry, cosine X plus Y. I'm gonna do cosine X, cosine Y. Remember, cosine changes, so minus sine X, sine Y. That's this to that. Plus, now we're going to do this one. It's going to be cosine X, cosine Y. Remember, cosine changes, so that minus sign turns into a plus. And I hope you see something here. This and this cancel out. So what we get now is 2 cosine X cosine Y equals the original one, cosine X plus Y plus cosine X minus Y. And now all I'm going to do is divide by 2. And I'm left with cosine X cosine Y equals 1/2 times cosine of X plus Y plus cosine of X minus Y. So I'm going to let you ponder that for a second, and then I'm going to pull up the other screen and show you the first identity. This is our first one right here. And again, you don't have to memorize these. I just want you to be able to recognize which ones you're dealing with and be able to apply them to a situation. So we have cosine X, cosine Y, and then the 1/2. Watch the first identity over here. Let me pull this up so you know what I'm looking at here. That one right there. Cosine X, cosine Y, A and B if you want. 1/2 cosine of the sum plus cosine of the difference. Okay? So the idea here is that all of these identities come from setting up this problem right here in its various forms. So if you look, there's other ones below it that are very similar to that all have this same form of cosine of something plus cosine of something, or sine of something, whatever it may be. All I want to do is I want to walk you through a couple more of these so you can show where these come from. Our ultimate goal is actually to generate this expression over here. So let's look at the next one, which is going to be, let me go over to the whiteboard again. The next one's going to be, I'm going to start with cosine of A minus B. I don't want to do A minus B again. I'm going to go X and Y. X minus Y minus cosine of X plus Y. Now, once I start doing this problem, I think you're going to begin to see a lot of similarities. Here's a cosine problem again. Cosine X, cosine Y, cosine changes. sine x, sine y, minus. Now we're going to have a whole big expression, and you got to be careful because that minus is going to distribute through the problem. It's cosine x, cosine y, cosine changes, minus sine x, sine y. Now where does that leave us? Well, cosine x, cosine y, minus cosine x, cosine y, they're gone. Who's chatting? I don't know if I need to read this chat or not. Oh my gosh. She fed him to the lions, dude. What, who doesn't know that?
Yes,
Now
she
there might be
did.
another
She
person.
did. She did.
There might be another person involved, they said. Or in, okay, or the, all right. I can tell you're being really productive in your, yeah, okay. It's so weird. All right, minus and minus makes a plus, so I have two of these. 2 sine x sine y equals cosine x minus y. And that means now that when I divide by 2, this goes away, and I get 1/2. And you see when I go back to the other side, the second one is sine x sine y, and we have the original problem with a 1/2 in front. So the two cosine problems lead us to the identities for cosine x, cosine y, sine x, sine y. I'm going to do the third one now, and I'm going to trust that you trust me that the fourth one's going to work. If you don't think it's going to work, I'll do it for you, but I don't want to kind of wear you out too much here. Let's look at the third one now that involves sine, because I want you to see how the sine identities work also. So now we're going to start with sine, and I'll tell you in a few minutes why I'm using x plus y instead of a and b. You'll see in just a second. Plus sine of x. So to be clear, the other identity for sine just changes that to a minus sign. And you can go do that on your own. It's not going to really change a whole lot. But let's see what happens here. All right. What happens with sine? We have sine x, cosine y. I'm asking you to remember your sum and addition identities. So let me pull them up again real quick. Here they are. Sine of a plus b is sine, cosine, cosine, sine with a plus, and then minus is minus. So you have all those handy. If any of you don't have those, I'll get them to you. But this is sine x cosine y plus cosine x sine. Plus, I'll change colors so you can follow it. Now we're going to do this one, which will be sine x cosine y minus cosine x sine y. And lo and behold, look what happens. Two of the terms cancel out. We get 2 sine x cosine y equals and then dividing by 2, puts a 1/2 in front, and we are back to the same form of the identity. I'm not going to ask you to memorize these. I don't think it's reasonable to do. Maybe if we're in a different world, we would have these memorized. But I want you to see that they come from something. They're not just made up out of the blue. They actually come from something. And probably until you work with these a little bit, you probably are like, oh my gosh, who would ever do this? And even while you're doing it, you're probably thinking, who'd ever do this? And let me just pause for a second. This is a section that leads almost everyone in pre-calculus to say, are you kidding me? I mean, this whole chapter, like, who does this? Who sits around and proves identities ever? This is not like the, when am I ever going to use this? Okay, you know that you're not going to use most of this anyway, right? No, but nobody ever does this. Nobody proves identities. Nobody cares what sine x, cosine y. Why does this even matter? This is the one time when I'm going to pull out the, what's the name of the course card? The name of the course is Pre-Calculus, which means it's designed to prepare you to be successful in calculus. Now, when will you take calculus? I don't know. Will you take calculus? I don't know. That's not what this is about. This course is designed to prepare you so that when you do take calculus and you run across trig in calculus, which is a massive part of calculus, you will be like, oh, I can see some value in doing that. So that's where we're at now. This is very much a pre-calculus concept. The stuff we're going to do moving on after this is actually a lot more applicable to what people might do in real life than this stuff is. This is very theoretical. I get that. It's dry. It'd be a lot cooler if I was in the classroom and we could have some fun doing this, but what are you going to do? You know, so anyway, okay, I'm done with that. So let me go back to the screen, the other side, and just review with you real quickly that these four identities are the ones that take us from a product, cosine, cosine, sine, 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 cosine, cosine, sine, to a sum, product to sum. And by sum, I also mean there could be a subtraction there as well. Any questions so far? Where did Ivan go? Ivan?
Something flew in his eye.
What happened?
Something flew in his eye.
Oh my gosh. Ivan, we miss you.
He's eaten by a bear.
I gotta feel like maybe. Shoot. All right. Any questions so far on what I've been doing? I've been doing all the work. You just kind of following along. Is there anything you want to go back and see or have explained? I got some examples at the very end.
Oh, well, I was just going to say, I feel like it's more useful when you, like if we just do examples, because they don't go very
Hard to follow all
in-depth.
this, right? Yeah, I get it. The only thing is I have to show you this. It's part of the contract that I have to show you how this goes. So just sit back and enjoy, because I know I'm really good at this, really exciting stuff. This is probably the highlight of the quarantine right now. Ivan, are you okay?
Ivan's dead.
Yeah, I'm good. I'm good now.
Okay, I know you're down to one eye. Did you lose your other eye?
It's the same eye.
Oh, okay, good. Well, no problem there then. Okay, well,
Sorry.
it's about to get weirder now then. And I'm going to go back to driving some stuff. Sorry, Anna, but I have to. It's part of the contract. Let's start with something here. I'm going to start with one of the expressions that I derived for you before. It was this one. Sine of x plus y plus sine of x minus y equals 2 sine x cosine y. Okay, that's one of the ones that I just derived. Might have been the one I just did, in fact. Yeah, it was the one I just did for you. Okay. Now you'll remember that the first thing we did was product to sum. Now I'm asking you to do sum to product. So we kind of have the makings of a sum right here, but I don't love x plus y and x minus y. So I'm going to do something I haven't really done ever before, and I'm going to do a substitution. I'm going to let x plus y be the letter A, and x minus y be the letter B. for reasons that don't probably make any sense to you yet. But I want you to watch this. It's pretty crazy how this works. So what I have now is sine of A plus sine of B, right? Because x plus y is A, x minus y is B. And the problem is, I mean, that's great, but the problem is I don't know what to do with these x's and y's. I know I can replace x plus y with something, but I don't have to do with x and y. But watch, this is great, this is cool. Think back to Algebra 1 days when you learned how to do systems of equations. You might have remembered you can add these together. The y's cancel, you get 2x equals a plus b. Does that ring a bell? Divide by 2, divide by 2. Now x equals a plus b over 2. Hey. Okay, that's one thing. Now I'm going to do something else. I'm going to erase this real quick. And now I'm going to do this thing. I can also subtract these. Which means x minus x means x's go away, but y minus negative y is now 2y equals a minus b. Divide 2, y is a minus b over 2. So now I have the ability to substitute for x and y. Watch. Sine A plus sine B equals 2 sine of A plus B over 2 times cosine of A minus B over 2. And that is one of our identities. Now let me go back to the other side. So look at this, sine A plus sine B, then it's 2 sine of something, cosine of something. I want to be really clear, this right here is A minus B. Look at the identities on your page. I'm looking specifically at this one right here. Right there. Sine A plus sine B, 2 sine, sum over 2, cosine, difference over 2. And they all work that way. So the first thing I started with was, let me go back to my sheet here, my whiteboard. First thing I started was sine of this plus sine of that. I won't derive any more from you because I hear you. This is dry and boring. But the other one comes from sine of x plus y minus sine of x minus y. That's one on your identity sheet. There's also one that comes from cosine of x plus y plus cosine of x minus y. That's also on your identity sheet. But the fourth one is a little bit goofy, and I want to show you that real quickly. So I want to focus here on these 4 expressions. Specifically, sine plus sine, sine minus sine, cosine plus cosine. All of those fit the model of what we've been dealing with. The one that doesn't fit is this one right here. Because you see it's not plus then minus, it's minus then plus. I'm not going to go through this with you. Yes? No. But here's the thing. I can get there by taking this, which is a plus, putting it first, and take this minus and putting it there. But that changes the order of a subtraction problem. So it requires that you include a minus sign out front. All of that leads down to, look at this one here. This is why I need to show you this. This one right here is the one of these identities that has a minus sign. It's the one different one. Cosine plus cosine, no problem. Sine plus sine, no problem. Sine minus sine, no problem. This is the one that leads to a minus sign in the problem. So when you look at these identities as a whole, you're going to see, oh, they look all pretty much the same. Oh, wait a minute, there's this weird random minus sign in front of one. It's because we had to switch things around to make it work. Okay. Sorry, I have to end all the fun now, and now we'll just do examples. So let's start with the first example. Here we go. Cosine of 13 pi over 12 times the sine of 5 pi over 12. Now, I'll tell you something here. We know that those are both half angles, right? 13 pi over 12 is half of 13 pi over 6. And 13 pi over 6 is a pi over 6 angle. I could figure out what cosine of pi over 6 is, or 13 pi over 6. I could do this as a half angle problem. I could do the sine part as a half angle problem, where it's half of 5 pi over 6. But now I've got to do two separate problems to fit this all together to solve one problem, when instead I simply have one of my identities here. I have cosine times sine. I'm looking at this one, I don't know if you can see, this one right here, the fourth one on that page. So let me go back real quick. It's cosine times sine. I'm talking about the bottom one right here. I can't highlight cosine times sine. So the fourth of the product to sum identities we can use here. And let's look at how we use it. We know that this equals 1/2. I'm just writing right from my notes here. Sine of A plus B. This is A and this is B. 13 pi over 12 plus 5 pi over 12 is 18 pi over 12. Minus the sine of A minus B. 13 pi over 12 minus 5 pi over 12 is 8 pi over 12. Okay, this is 3 pi over 2, and this is 2 pi over 3. So 1/2. What's the sine of 3 pi over 2? Who knows?
Is it 1 or 0?
-1?
It's -1. Yeah, good answer. It's at the bottom. So -1 minus, and sine of 2 pi over 3?
Negative the square root of 3 over 2.
Close, but it's positive.
Oh, it's positive.
Because 2 pi over 3 is in quadrant 2, still on the top side. So that's what I have there. To be clear, I've got this minus that. So I'm left with minus 1/2 minus root 3 over 4. And that's one, this is only one example, and not all of them, but it's one way that I can turn a product of kind of unusual cosine and sine values into a number I can actually come up with. Not something I type on my calculator, but something I can actually give as an exact answer.
So when we get to that, like, that's the answer. We don't have to
Yeah.
do 1/2 minus root 3 or whatever.
Well, I suppose you could simplify this to that. You see how I did that? Turned the 1 over 2 into 2 over 4. But either one of those is fine. I'm okay either way. It's exact enough to me. How do you feel about this type of problem?
Good.
Okay, I'm going to show you. Your assignment is not from your book. Your assignment is from on a worksheet, and I'll show you the worksheet before we're done here. And I think you'll see. Oh, I can work that out. No problem. Okay, let me show you example number 2, and then I'll be done with examples. Then we'll look at the assignment. Example number 2. Sine 4x minus sine 2x equals 0. Hey, solve. And you should look at that and you're like, I don't know what to do. I know that I can do some sort of weird stuff with sine 2x. I know double angle there. And I can maybe think of this as a double angle with 2x, but it gets really, really messy if you try to break this down using our previous identities. But then you say to yourself, wait a minute, that's sine A minus sine B. That is this fourth identity right here, which means equations that might have been really messy before now aren't so bad. Sine A minus sine B. Let's look and see where that takes us on this problem. We have sine A minus sine B. I'm working with the left-hand side now. It's going to be 2 cosine. Now I'm adding the angles and dividing by 2. Adding those and divide by 2 gives me 3x, right? Does 4 plus 2 make 6x divided by 2? Then sine of now the difference between these, which is 2x, equals 0. Now I want you to notice a couple things. First of all, in this problem here, don't ever believe that there's anything you can factor out of this. Like, don't say you can factor out a sine, because sine is not a number. Sine's a function, so you can't factor anything out here. The other thing I want you to notice here is that I've got number times number times number, or more importantly, factor times factor times factor, all equals 0. What does the 0 property tell us?
On the sine 2x, wouldn't it be 4 minus 2 divided by 2 is 1?
It would be. You are so correct. Good call. Yeah, 4 minus 2 is 2, divided by 2 can become sine x. Great. So, what can we do with factors that multiply to make 0? Well, either 2 equals 0, which it doesn't, or cosine 3x equals 0, or sine x equals 0. These are problems we know how to solve, right? Maybe? Where is sine x going to be 0? You tell me, where is sine x going to be 0?
Zero and
At 1.
yeah,
1.
I heard 0.
Or 0. Yeah.
And then
0
what
and
else?
-1. -1.
I mean, I'm thinking pi. Left side of the circle? Isn't it here and here? And then 2 pi? And then 3 pi? Oh. So n pi? How do you feel about that? I don't feel like you're all super happy about that. I want you to be happy. Okay, we'll feign happiness. Okay, got it, Anna. Thanks. Appreciate the encouragement. Okay, now where is cosine going to be equal to 0? Think about that. Where's cosine equal to 0 here?
pi over 2.
3 pi over 2.
Pi over 2, 3 pi over 2, that's here and here, 5 pi over 2, and so on, right? So as long as 3x, watch this carefully, equals pi over 2 plus, oftentimes we'll be adding 2 pi, but it turns out this pattern just goes top and bottom, adding pi at a time. It's pi times n. So as long as 3x is a pi over 2 angle, that is top or bottom, cosine will be 0. Now, the way I solve this is I have to divide by 3, and I end up with x equals, watch this carefully, pi over 6 plus pi over 3 times that. And those are my two answers, or two sets of answers. So there's a lot going on right here. And let me just summarize what we've done. Everything from that line down is basically a review of algebra with a little twist of solving trig equations. But setting things equal to 0, writing them as factors. The benefit is that I was able to write these as factors. The part from above down here is the new part that took this sort of simple looking but sort of confusing looking equation and turned it into an algebra problem that we can reasonably solve. So this is where there becomes some value in having these product to sum and sum to product identities, in that we can take a sum, or a difference in this case, that would be difficult to solve and turn it into a product problem that we know we can solve using the zero product problem. From this point here down, I'm guessing you're all at different points in your confidence level of doing that. You all did that fairly well in your quiz. I don't know if one of you did it and showed the rest of you how to do it or what, but I'm not sure if your confidence is as high on that particular process as I'd like it to be. But we're at the point where I expect you to be able to solve a problem like this and a problem like that pretty successfully. So as a preview of your test that's coming up next week, definitely expect that a problem like what I've just circled there in orange is a reasonable thing that I'll ask you to do. That might be secondary to applying one of these identities to get to that problem, but I also want you to be able to get down to these answers as well. So, and I hear you loud and clear. Derivations are not fun, and it's really dry stuff here. But sometimes doing examples can be a little bit daunting as well. It can be a little bit overwhelming, a little bit intimidating, but they do give you something to build from. And something to say, oh, I've never seen a problem like that. So what I want to do real quick is pull up the assignment sheet. I'm going to go to here to get it. And I'm open for questions too. I'm not just trying to blow you off, but let me go here first. So here's your assignment. And do you see, just take a good look at those. Do you see how those are just product to sum problems?
No.
Cosine A, sine B?
But like, what about like the numbers? That's what, because like 84 and 129, no thank you.
You're not actually going to have to answer these. You just have to write them as a sum or difference with positive arguments. So like the answer for number 1 is that. You see that?
Mm-hmm.
Now, are these degrees or radians? I don't know. There's no symbols on them, so I would treat them as radians. But you're not going to have to do any of that until we get down here. These you can assume are degrees. So does that look any better, 15?
What are we supposed to do like when there's like the 4 out in front, like on 17?
You just keep it out in front. You do the problem as if there was no 4. You're going to answer like minus 1/2 minus square root of 3 over 2. Then put a 4 in front of it and just multiply that through. So don't let the 4 or the -3 or the 2 throw you off. Just ignore them first, do the problem as it is, and then put it at the very end, and you can distribute it as you need to. So like on number 17, I don't know what the answer is, but I'll look here. I'll look at the answer to 17. It's 1, which tells me that sine 75 times sine 15, it's probably going to come out to be 1/4, right? So I get 1/4, then I multiply it by 4, and off we go. Take a look at 9 through 14. Write each sum or difference as a product. That's it. So look at number 9. Here's 14x sine 2x. Answer to number 9 just has a bunch of stuff with cosines and sines and x's in it. So for 1 through 14, you're just going to be rewriting them in proper form. And the last 6, you can actually be calculating numbers. Okay? So this is a little bit of busy work, I'm not going to lie. But it's intended to get you faster at this and feeling a little bit more confident with this so that you're not freaked out when you see one of these. I'm not saying that if you ever come across this on the street one day, you'll be like, oh, that's a product of some problem. But I'm saying if you come across it and you're doing work, you're like, hey, wait a minute, that looks familiar. Let me pull out my identities. Right, there's a product of some, I can write it in that. Okay, that's all I got. What about some questions? Is there anything you're missing that you need from me at this point?
Will to live.
Okay, well, I'll work on that. Yeah, that's going to be a tough one, but I'll see what I can do. More importantly, do you all have all of your identities? Okay, I can. If you need them, you let me know. I'll send them an extra copy. I can post them on the website if you need them, but use those as your reference. This is not going to be a memorization task. It's an applying task. So do that. Let's talk about this week then. So tomorrow is going to be a review assignment over everything in section 5. You're going to see some problems that you've already done before. You just do them again. Maybe it'll make more sense a second time. I don't know. It's a lot of like multiple of 5 problems. Thursday is going to be a review. I will do my best to have a little video put together for you, probably a 5-10 minute tops. Excuse me, for Thursday, that will outline what it is I really want you to be able to do from these 5 sections. And a fairly lengthy review assignment, but that just covers all things. Just do what you need to do to get ready for your test. Friday is a study day. You can have more time if you need to review things. You can ask me questions, check with me, whatever you need. You got the entire weekend. I will have your test up and ready by Friday. I'd like to have it back by Monday. Is that reasonable? Okay, so I'm not going to put any time constraints on you and much time as you need. I just want you to be able to demonstrate that you've got some abilities with these identities. Anything else? All right, look, we're almost at the end of this really tough stretch of trig. I think it gets better from here. And I don't say that lightly because I know that this has been really, really hard. And we were making some good progress and we just lost our momentum right in the middle. So hang in there. The test is not going to be something designed to just crush your will to live. Maybe even it'll restore your will to live, Lucas. I don't know. I can hope. It won't be terrible. I want you to be able to do fun things, some very useful things, not grind things that are not fun. So we'll shoot for that. The next time we'll be back together probably should be next Tuesday. Want to mark that, the 21st? That'll be the next day we're back together. We'll try to have your tests that I can go over some highlights, but I'll go over them individually with you when you send them in to me. And we'll be starting in on the next topic, which should be Let me double check. It should be chapter 6 in your book. Let me just confirm. Yeah, chapter 6. And then the last thing we'll probably do is the last, probably half of chapter 10. And that'll be that. And I'll decide where in there we'll have our final exam. I just got an email from Dick Trudgeon, the guy who came to our class today, and they're trying to figure out what to do about finals, whether we drop topics or so on. And I still think we're going to be able to cover everything just fine. But I'm going to look back at the final exam, and I'll make a decision what we're going to do. He also talked to me, just to kind of get you thinking in the future, about whether we want to do it in a 3-hour block, or if you want to break it up into 3 parts, maybe even 1 hour over 3 days, 1 hour a day over 3 days like we did before. But he did say it should be the same hour each day. So you should all be testing at the same time. He mentioned one option is that we set up a Zoom like this and I watch you take your test. And I got to tell you, if you think watching me derive identities is boring, you haven't watched a group of students just take a test for 3 hours boring. So I prefer probably not to do that, as much as it is fun to watch you do what you do. Probably I will write up some sort of proctor form and ask to have a parent sign a proctor that you took it and we're not consulting whatever you're supposed to consult on. Okay, so I'll work on that. That's probably not going to be for another month or so, so I wouldn't worry about it yet. I'll figure out a time. The last thing I want to tell you is that I have been told that the official last day of school is now June 19th. But that we can probably, it's not for you seniors, we will probably be able to quit or shut down new material by the 12th. And the last week is just for makeup work, which means we might shut down or quit a little bit earlier than the 12th. We might end when the seniors have their last day, which could be anytime. Anyway, I don't know when we'll do that, but I don't feel I need to go all the way to June 19th. We'll get our work done, and we might even shut down after the final. Who knows? Okay. All right, guys, be good, seniors. I'll see you in half an hour, I hope, at our senior meeting. Hang in there. Keep working hard. I miss you. Be good. Bye.